Hey, it's Mrs. Moret with help on today's assignment, Unit 5, Lesson 4. All right, this is in your textbook on page 313, and you're doing numbers 1 through 6. So let's get started. Number 1. The dash function is the graph of f, and the solid function is the graph of g. Express g in terms of f. So that means that we want to start with g of x equals. And so when I look at the two graphs, it looks like they're symmetric over the y-axis. So that means it was a horizontal reflection, which means then that it's a change in the input. And so when I look at the g of x point, let's just say right here, it's a reflection over the f of x point, and so the output has stayed the same. It's the input that's changed, which means this is equal to f of negative x, a reflection or a change, the negative in the input. Number 2, I'm going to start this one just kind of using a process of elimination. So the table gives some values of functions f and g. So here's x, and then here's f of x, and here's g of x. So in order for the first statement to be true, all of these would have, f of x and g of x would have to be like one's positive and one's negative. And that's not happening. They're all positive. So both A and C cannot be true because that negative means the f of x column or the g of x column, they'd have opposite signs of each other and they're all positive in both columns. So it can't be A or B. And then statement D would mean that at each step for each value of x, f of x and g of x are the exact same number, which is also not true. So it has to be B. But if we want to take that a little bit further and kind of think about, this is exponential decay, right? It's like multiplying by a half, whereas this is exponential growth. And so what would make that happen to change from decay to growth is if this was a positive 2 and this was a positive 1. The 0 is the same. If this was a negative 1 and a negative 2, then we'd be working with negative exponents, which would create some fractions, which is, if it's exponential decay and then we use negative exponents, then it would actually create some whole numbers. Okay, so it is definitely option B. But again, like, you could totally have figured that out by a process of elimination. All right, number 3. Here's a graph of function f. Sketch a graph of f reflected over the y-axis and then translate it 3 units up. So we're going to first reflect over the y-axis and then translate 3 units up. So I'm going to just pick a few points to do that with. And I think this is a good point here. Obviously, the intercepts are going to be good points. And then maybe, like, it looks like about negative 2, kind of negative 5, and then maybe 4, 5. That looks, so those look like 4 pretty good points. So we're going to first reflect and then shift up. So we're reflecting over the y-axis. That this point here is on the y-axis, and so I'm just going to shift it up. So it looks like it's at about negative 3. So up 3 would be at 0, 0. And then for here, I'm going to go reflect it over and move it up 3. It's about there. And then for 4, 5, reflect it over, -4, 5, and then up 3, it's about there. And then for the last one, -2, -5, I'm going to reflect that over and move it up 3. So it's about here. Okay, and so the last thing to do is to give it that twist. And so looking at this, I think it's going to be like this, and then kind of like that. It might not be the best, but you get the big idea. All right, moving on. Number 4, the first thing that I would do is like connect those 2 points. We have to describe a transformation of this line that contains the 2 labeled points, these 2, okay? So if we were to transform this line, so then it goes through a line that contains those 2 points, I'm going to first draw this line here, and it, gosh, they clearly don't have the same slope, so it's not going to be a matter of just like shifting, because they don't have the same slope. They'd have the same slope if it was going to be like a horizontal and vertical shift, or I should say vertical shift, they'd have the same slope. And so one thing we could do is extend and see like where do these lines cross, and it's going to be off the graph down there. And if I labeled this point P, then I could say like rotate about point P until you meet up. The other thing that I would say is like this point will map to that one after the rotation, and this to that one after the rotation. Okay, so that's kind of the best idea there, is just to rotate about that point, because there isn't like a shift or a reflection that will get there. Number 5, we have 2 different functions going on having to do with temperature in the apartment. So the thermostat in an apartment is 75 while an owner is awake, and then 60 while he's sleeping. The function W of X in degrees Fahrenheit is the temperature in the apartment X hours after midnight. So W of X is our initial function. And then it says when it's hot outside, the owner changes the settings to be exactly 10 degrees warmer. So exactly 10 degrees warmer is going to be an increase in the temperature, which is the output, and that will save energy. So now we have the function H of X, which is still in hours after midnight. It's just that it's going to be 10 degrees warmer. So if W of 6.5 equals 75, then what is the corresponding point on H? So H of 6.5 would just be 10 degrees warmer. So it would equal 75 plus 10, which is 85. And then if W of 2 is equal to 60, the corresponding point on H, again, would be H of 2, which is going to be 10 degrees warmer, so 70. And then part C, write an expression for H in terms of W. So H of X, which is the temperature when it's warmer outside, is equal to the original setting of temperature, but then plus 10. So again, since the temperature change, it's the output, because X represents the time. The time is not increasing by 10. The temperature is. So we have to have that plus 10 on the outside of the parentheses. All right, and then finally, number 6, a ball is hit in the air. Its height h in feet t seconds after it's hit is modeled by the equation h equals 4 plus 50t minus 32t squared. Which equation models the height of a ball following the same path, but is hit 2 seconds after the first ball? So we know the output h is the height, the input t is the time. So if we want to do 2 seconds after, 2 seconds after, that's a change in time, so a change in the input. And remember, when you do input shifts, it's always opposite the expected sign. So we might think it's going to be C, where we add 2, but it's not going to be that. It's going to be subtract 2, because with input changes, you always do the opposite operation. So it's actually option D. All right, so the initial height of the ball is 4. So this would be increasing the height by 2, not the time, 2 seconds after. This would be decreasing the height by 2, again, not a change in the time, which is what we're looking for. This would be 2 seconds earlier, since it's plus 2 and opposite signs for input. And then this would be 2 seconds after. So that is the correct one that we chose. So that is the end of your assignment. I hope the video was helpful.